Let's see another example, how to reduce the setup time on a very normal semi-automatic machine or an automatic machine also. So in the previous example, we have seen how we can use SMED method to reduce the preventive maintenance time. In this example, we are using the SMED method for setup reduction. All the activities in the setup are not very special activities which are performed only on this machine. I'm pretty sure that some of the activities or most of the activities which we are going to see or we are going to optimize through this method can be used by you on your machine, can be optimized based upon how we are going to think in this example. So in this example, we have taken one automatic machine and we have here recorded the setup time. As previously mentioned, I always recommend wherever possible to do a video recording of the setup time, so that later on we can discuss with the team, we can go through some activities again and again and we can discuss. It's really much more beneficial. In this particular example, we have here in total 10 activities. First column we have all the activities, and after that we have the time from to, so the starting time for a particular activities and the finishing time of that particular activity, and in the last column we have here the total time required for that activity. So here we start. Let's go through all the main activities which are being performed during the setup. First of all, the activity number 1 is that we empty the machine so that the last part of the last order is out and the whole machine is empty. After that, the machine operator is counting the quantity of the good parts and he's counting the scrap and he's filling the paper. The job order in ERP is going to the computer and registering the finished job order there. Activity number 3 is transporting this finished job order to the next process. Then he's going to the storage area and to the previous process and bringing the material for his next job order. And then he's again going for collecting the tools, jigs, fixtures and other parts which he requires for the setting. And then he comes back to the machine with these parts. And then activity number 6 is that he's actually changing jigs, parts or the other plates there. Activity number 7 is that after setting up, then he's starting the job order. He's feeding the material, the new job order, and he's starting the machine. And activity number 8 is that after production of first part, he's stopping the machine. Activity number 9 is going to the microscope. He's checking the part visually if everything is okay, and he's checking the main dimensions of that part. And if everything is okay, the last activity is that he starts the machine. So these are the main activities which are very common in most of the automatic machines. And here with this example, we can see what are the ideas and how we can implement SMED method. The very first step is to categorize activities into internal activities and external activities. Here we have a very good mix of internal activities and a lot of external activities. The step number 2 is to externalize all the external activities. The activity number 2 is count the quantity and the scrap and fill the papers and do the entry in the ERP system. This can easily be done after starting the machine with new job. So this is an organizational issue. Through the training to the operator, this can be easily managed. Then we have the activity number 3, transport the parts to next process. So it means after finishing the previous job order, the operator was transporting, but this can be done after starting the new job order. Activity number 4 is bringing the parts and the material for the new job order. Actually, this can very easily be done before the machine was stopped, before the machine has finished the running job order. So operator could have easily prepared everything, and when the machine is stopped and has finished the running job order, then he or she could have started with the setup time and not then going to the previous process or to the storage and bring the parts. Activity 5 is to collect jigs, fixtures and the other parts This is also in a similar way as the activity number 4 that could have been prepared before the machine has finished with the running job order. Similarly, the activity number 9 is going to microscope and performing the visual inspection, checking the dimensions. And this is the external activity. This we can easily externalize that we perform this activity and the machine is running. So here we might have to talk with the quality department and we have to show the risk analysis that how many times in previous years or in last year this has happened that the first few parts were defective. Currently we are stopping the machine for this activity so that we don't produce the scrap. But if the total scrap cost in previous 1 year is lower as compared to the cost of not running the machine, then we can easily convince the quality department and the management that we want to go with risk because we are finishing this activity anyways within 3 minutes and we are coming back onto the machine, and we can stop the machine in case during the inspection we know the parts are not passing the inspection. So with that way we can externalize this activity and let the machine run, and we can reduce the total setup time here because all the external activities mentioned here are not done when the machine is being stopped but are done either before the running batch is finished or after the new job order has been already started. So in this example we have reduced approximately 51% of the setup time just by externalizing the external activities. The step number 3 is to convert the internal activities to external activities. We have here the activity number 6 in which we are really doing some setup. We are changing the jig, we are changing some plates, we might be changing some bits, we might be changing different parts, and the improvement potential is here that instead of changing small parts in the head, we just change the whole head. Let's see an example for the milling cutters. It might happen that after a job order is finished, we check which bits are worn out, we have to replace, we change few worn out chips and we align them, we put the new one and we tighten them. Similarly, it could happen for the turning tool also, that on lathe machine we have seen the bit of the turning tool is now gone and we have to replace it with the new bit. This takes a lot of time. Instead, what we can do, we can prepare another head, another turning tool, another milling tool which is already ready, and as soon as the job order is finished, we just replace the whole head with the new already prepared inspector head, and we are finished. We are very quick with the change. Now we can say that all of us are not dealing with these simple heads, turning or lathe machines. I have seen this idea applies to most of the special purpose machines. It doesn't matter what type of machine we have. Most of the time that we are spending a lot of time replacing one small tool or some wires or anything on that particular head. In case we take the complete head out and replace it with the new head, which is anyway in the company as a spare part available, then we are much quicker and we have offline a lot of time to check, inspect and do a very good quality setting, and the machine downtime for doing this activity can be drastically. Similarly, there could be during the setup time we could be changing some plates, and in traditional way there are a lot of screws, bolts, nuts we have to open, and we can question when we are doing SMED analysis. If there are, for example, 9 bolts, then we can ask, do we need 9 bolts here, or we can just have 4 bolts and they will function the same. Similarly, we can also ask if we need to have bolts at all, because to screw and unscrew a bolt we need spanner also. But instead of that, we can have one wing nut in which we don't need any tool. An operator can simply with hand can rotate and open or tighten the screws. Other ideas during the setup time you can think of is how the fastening or tightening of the screw is happening. For example, in traditional way, we are opening the whole screw. A screw might have say 28 threads. So in order to remove a particular plate or a part for the setup time, we might have to rotate a screw 28 times and then remove the screw, and then we can take. This is 28 threads per screw. If we have more screws, then even it's more time consuming. In a more lean way, you can have pear-shaped holes in which you just have to open one thread of a screw. After turning one time, the plate will be loose, and then you can slide it in one direction and you can easily remove a plate or any part. So it's one thread loosening system here. Or there is another idea in similar cases that you can have C-slots instead of traditional holes, in which you just unscrew one thread of the screw, and after that you can just slide and remove the part. So these are the ways in which you can speed up the whole replacement of the parts during the setup time. So in case the setup time involves any fastening or any clamps with bolts which requires spanner or other tools, that you can also check. There are in the market a variety of clamps which don't need any type of spanner, Allen key or anything like that. They can be just simply with hand, can be clamped and can be very easily opened, and that eliminate the whole work of loosening, removing the packing plates and replacing the packing plates as per the height of the parts. Everything is eliminated if we have this state-of-the-art clamps which are very easily available in the market. So here in our example we have seen for the activity number 6, we have a lot of ideas, and depending upon our machine, our setup, we can use some of these ideas or other ideas, and we can speed up this change process. In our example we have seen we want to change the whole head, and then we have reduced here the time for this activity from 7 minutes to 2 minutes. The step number 4 is to improve the internal activities or eliminate that. So in our example, the activity number 1 is to make the machine empty, and also the activity number 9 is then again fill the machine. This is a very common practice that when a job order is finished, we are emptying the whole machine, and that takes some time depending upon how long the line is or how long the machine is. And after that, when we start the new job order, the same time is required. The main reason behind that is we want to be sure that we don't mix the parts from last order with the next job order. So in order to avoid that, we are wasting our production time just to run the machine empty. So this can be avoided, and after finishing the one job order, before starting the another job order, we can put dummy parts in between them, maybe one part or few parts. The dummy parts which are either different in shape or they are very different in size, so that in the end when they reach to the last station, the worker can easily distinguish that here is the end of last job order and the start of the new job order. And then he can stop the machine and he can change the containers and everything without losing this 20 minutes to make the empty, 20 minutes to refill the machine. So we can save 40 minutes very easily. In case we cannot rely on the operator, we can also think of if we have any limit switch or any sensor which can sense that my dummy parts are different in shape or different in color, and as soon as these parts reach to the end, the sensor or the limit switch will be triggered, and the machine will be stopped, and the operator goes and separate the job orders, and after that run, and we save a lot of time with that. So in our example, with a relatively smaller line, we have saved here 3 minutes, because earlier for making the machine empty and filling was 5 minutes for each activity, and now we can finish the whole process in less than 3 minutes, in 2 minutes. Step number 5 is to improve the external activities. So we are not reducing the setup time, but we are trying to reduce the non-value adding activities, or we are trying to reduce the waste in the production and save the time of the operator. The activity number 2 is to count the quantity, to print out papers, and then fill the papers, and then going to the computer and doing the entries in the ERP system. And for that, one idea would be to check the layout plan if there is any potential for improvement. Maybe in the current state the operator has to go to computer, take the material tools and to the printer, and all that they are not in a right sequence, or they are not in the optimized layout. And if we optimize the layout, maybe it's very easier for operator to do do very quickly and move from one station to another and save a lot of time. Another ideas could be that we use barcodes. A lot of time I have seen that the operators are really writing on the paper the numbers, the quantity, the operator number they are writing, the machine number they are writing, which can very easily be scanned with barcodes. For example, every machine has its barcode. When the job order is finished, the operator is just scanning the barcode of that particular machine and done. So there are many ways to optimize all the activities. Next activity is the activity number 3, in which the parts, the finished job order is being transported to the next process. So this is taking some time. Here we can brainstorm with the team that how we can make it quicker, more easier. Do we need the adjustable trolleys? Will that help in this particular case? Or can we have some conveyor belts so that the operator doesn't has to go from one process to the another process every time when the job order is finished? With a simple conveyor belt, he can place the parts on the conveyor belt and simply press the button, and parts will be transported to the next process. The activity number 4 we have here: bring the parts and the material for new job order from the storage area or from the previous process. So in this case, what we can do is that we use our skilled operator only for the machine, and for such activities, transporting the parts to the next process or bringing the parts from previous process and the material to the machine, that can be left to unskilled operators whose job is just to go through all the processes and see if there is need for any raw material or the parts, and then they are continuously transport. Benefit of this would be that normally the skilled operators on the machine, they are expensive and they should not do the unskilled activities like transporting the parts and everything. So we save the time and we save the cost for the company by implementing such actions there. Also, we can check if there is really a need to go far away to bring the raw material, or some of the raw materials can be stored directly near the machine or on the machine, that after job order is finished, the operator or logistician must not go too far away and bring the parts from there, if that could be stored near the line. The activity number 5 is to collect the jigs, fixtures or other tools for the setup time. Typically, this can be optimized by setup trolley. I have seen mostly in one process where you have 4 to 7 or 8 machines, we need 1 to 2 setup trolleys, and whenever this next setup is, the operators are bringing the trolley where all the tools, all the parts are available. No need to search anything. And through the visualization of these trolleys, it is clear if there is any important part, spanner, plier or anything is missing, that can be seen before the machine is stopped, and then it can be placed again back into the trolley. And when we start with the setup, everything is there, and the trolley sometimes serves as the checklist also, in this case, that you haven't forgotten anything, and then we save a lot of time of searching different tools. The activity number 9 is another external activities which can be easily optimized. In this example, we have seen that we are going to microscope, we are checking the dimensions there, which can be easily optimized. The visual inspection is mostly unreliable. We have to do MSA every year and we have to train the worker in the production, and still we have a lot of manual error. So this can be optimized by automatic optical inspection. If we have down the line manual inspection process, then it makes sense to have AOI, so that down the line we don't have to do any additional inspection. We save the cost because normally the AOIs are expensive. But in case we don't have any manual inspection down the processes, in that case, only to the setup time quicker, we cannot buy AOI. In that case, we can think of any small camera system. There are plenty of cameras available in the market, and we can install that camera in the machine, which can detect most of the errors in the part, not all. And in that case, we can avoid during the setup time that we have to stop the machine, we have to take the part out, we have to do the inspection, and if the parts are okay, then we have to run the machine. So that can be seen, and easily if we have a simple solution for just one camera, that should not be expensive than the time we are spending or we are losing by stopping the machine. And by calculating the return on investment, you can decide if we can install a small camera system or not. Another activity is here done is that we are doing the dimension checking, which might be done with vernier caliper or other methods. It can be done, and at every cost that must be avoided, that operator has to set, he has to use an equipment like vernier caliper, check it. It's more time consuming. So instead, we have in the market a lot of gauges, no-go gauges, pin gauges. We have a lot of variety of gauges, which makes this process very quicker. So the operator doesn't have to see or has to read the reading also. What is the reading on my measuring equipment? An operator can just simply with the gauge can check if the part is going in this gauge and not going in, if this is right or wrong. Very quick and very reliable method. Last but not least, we have the step number 6, and in this step we aim for completely eliminating the need of setup at all. So in this step we are asking the team members, or research and development also is included here, to go for the design changes, that if we have 2-3 different articles, that can we reduce the number of articles with that. In this our example, we were supplying to few customers where on the same product only the number of pins were different. Some were having 2 pins, another were having 5 pins, another were having 10 pins. And with the simple change in design, and after talking to the customer, the result was that few customers did not have any problem if we supply them the parts with more pins. The cost of per pin was very less, but it reduced the number of articles in the production. So we need not to do very frequent setup change, and also in our ERP system we have to maintain less number of articles in this case, so reduced. So we have, instead of 10 recipes, we will have 5 recipes. So if there is any change in the parameter, a number of articles, and if we reduce the number of articles, the recipes in the machines we have, that will also enormously benefit the production. So in the end, we can see here the results. After applying this SMED method, we have seen that we could reduce the total setup time approximately by 80%. So, and this was the first time implementation. You can apply this method 2 or 3 times again after a few months, and you can really harness the benefit of using this very effective yet simple lean tool. Here in this example, we have seen that we could reduce the setup time from 36 minutes to 8 minutes. In your case, if it is not that much reduction, but still there is a huge potential. If we use this tool, in normal cases 50% of the reduction in setup time is very common when we apply this method first time. If you have liked this information and the videos in this series of single minute exchange of dies, last request from my side, just don't leave this information here. After watching this, go in the production area and look out for your bottleneck process. On the bottleneck process, see how much is the setup time through your OA data. In case the time wasted for the setup time is more than 3% or 4%, definitely there is room for improvement, and you go and apply SMED method as we have discussed here in these videos. And after that, don't forget to calculate the benefits, either the output in euro or reduction of inventory or reduction of lead time, all the benefits what we have discussed previously. Don't forget to mention that, to calculate them, and if possible, calculate them dollars or euros. And after that, you can show these results, especially in dollars or euros, to your management, and let your team shine through your results. And then you will get more resources and more focus for similar future projects, and that will benefit your team and your company enormously, because this tool is very simple but very effective to improve the productivity, to reduce the cost, and to have an enormous competitive advantage. Thank you.